Dmytro is the CEO of DeepXHub.com and a member of the Forbes Technology Council. Since 2015, DeepXHub has provided full cycle computer vision solutions for the prevention of high-cost incidents and fatalities, including quality of operations, safety compliance, and quality assurance monitoring for large enterprise customers and 5,000 plus employees. So think air transportation, warehousing, mining, and government, and custom solutions for startups. So DeepX was founded by immigrants from the Ukraine and is family owned and operated. So yay, go Ukraine. With that, I will let Dmytro show the amazing work that he does using our tools, and the floor is yours.
On my part, there would be like kind of small agenda. We are starting with explanation of what my company is doing, what is computer vision applications, how we are using DVC, and we will slowly transition into automated computer vision using quality assurance process using the CML and DVC toolkit. It's gonna be in some cases a little bit high level. My goal is here to share the vision, to share our experience. In some cases, it could be a little bit technical. I don't know you guys, unfortunately, yet. I don't know like if you need like more technical, more visionary stuff. But feel free to ask any questions when you have a chance. So basically, DeepXHub, what we are doing a full cycle computer vision applications. And what I mean by full cycle computer vision applications is that we are taking care of everything, including data gathering, data labeling, augmentation, generative synthetic data. We even have a custom hardware, and we are starting a new project soon when we are going to be launching our custom hardware in like literally into space. So we are building up some more different verticals here, but anything what is required to do and deliver the computer vision applications, we are taking care of the whole pipeline. I'm not sure if how you're interested in hardware part, I will share the slides after the call, so you could take a look into this video. But basically what we are doing here on hardware side, we have a custom AI camera box solution, which has stereoscopic vision and some NVIDIA Jetson processing power inside. We will not spend too much time on this. I will give you a quick example, one of large enterprise projects which we have in production for a couple of years already. Basically, what we are doing here, we are using computer vision for quality of operations monitoring and safety compliance. So we are using computer vision to understand how fast and how accurately team on the ground perform their work. If there is any issues, if we can help the team to learn something, to increase their quality of their operations and in general to be safe. The problem is in such environments and similar environments is the cost of potential issues or potential accidents. Unfortunately, in many similar environments, when we are talking about safety compliance monitoring, OSHA compliance monitoring, the cost of potential incidents is like in hundreds of thousands of dollars. And even in like warehouse and transportation, air ground transportation, handling, and so on, there is even fatalities happens every year. So we are using computer vision to prevent these fatalities. We are using computer vision for quality of operations monitoring and other stuff for vertical clients. If you're interested to learn more, there would be additional videos and presentation. Also, we have some open source solutions. The link will be provided. Most interesting part, the DVC. So basically what we are using the DVC for. I will not be explaining all the details of the basic. You're probably very familiar with this. If not, just go to dvc.org. Basically, DVC provides a capability to have a good versional controlling. It provides us a capability to repeat our experiments. It provides us capability to reproduce our sometimes mistakes, sometimes like extremely good findings, and it gives us opportunity to much easier collaborate between different team workers, between different geographies. Our team is fully remote. We have like 30 people right now. Significant part is based in Ukraine, but there is like in Europe, in Germany, in Italy, some guys in Nepal, some guys in San Francisco and California. And it's really like worldwide distributed team. And using DVC, there is like multiple great benefits for us. First of all, we are leveraging like the basic pillars. We can have a properly managed experiments, and this enables us with predictability and repeatability of our outcomes. We have proper data control, and we can easily reproduce a specific version of computer vision machine learning experiments. So I will provide some examples where it's particularly beneficial for us. But for me, one of the biggest values here is being able to easily onboard new computer vision engineers. When we are starting working on new particular computer vision task, it always takes a lot of time to understand what exactly was done prior to current state, what is the motivation behind the changes in the data, and we always like kind of juggling between like different sources of knowledge, different sources of truth, to understand what exactly going on and why we are in that current state. One of the examples of where DVC really helps us is layout machine learning experiments. Without DVC, we have been like doing a lot of custom documents in Confluence or Google Drive describing the experiments, and to get the true understanding of what went wrong. Usually it required us to go like in Jira, go to Confluence, have some custom documents in the Google Drive, but there's always was this factor that somebody will forget about minor change to data, which they made just like at Friday's night or something, and it's impossible to remember that there was this change. And usually these small changes have a drastic effect on the total accuracy of the and predictability of the solutions which we provide. And especially because we are working with large enterprise customers, and we take responsibility for long-term production maintenance, it's really important for us to have a system and solution which helps us to maintain the good version control and good accuracy. And with DVC, it's many of these problems is actually being solved with a couple of simple commands. We are just like we are doing just basically DVC pull to get the specific version of data and code from Git associated with a particular experiment. So if there was a failure, or if there was something really interesting, which we want, some interesting experiment which we want to continue from, but we hadn't had the resources on time to continue, we could easily like to return to this particular state of experiment, particular state of development of computer vision task, and continue on from that state. That's a basic beauty of DVC for us. And in our use case, I briefly touched it already, so new team member is joining, and it's much easier to set up the environment, and we don't need to download the whole data set anymore. We don't need to look into like tons of folders and subfolders to find the particular snippets of the data. We are just like we are pulling particular commit, particular branch from Git, and new employee is ready to go. So that's a beauty of DVC. On CML side, I don't have like particular detailed diagrams here yet. I will add maybe a slide after this for simplicity. But basically, it helps us automate the workflow. why this is workflow of development and deployment of our computer vision models and our computer vision experiments. Why this is important? It's particularly important when we are like doing. So it's getting much more important depending on how often you do the separate experimentation with your machine learning models. So if you are running some just like once per month, once per week, some changes, it may not be yet that available for you. It depends, but may not be that available. But as soon as we are approaching the scale for doing at least one deployment per day, or even I think one per week, it's already like a good tool to look into. And the third tool, which I will briefly cover on today, is DeepCheck. So basically, that is open source Python library, which helps us to automate the quality assurance of our computer quality assurance process for testing for our computer vision models and models and modules. How it works, it provides a validation for training, test, and train datasets, test and validation datasets. It helps find common mistakes as like image leakage, like some disbalances in different types of the data, and it helps us to discover potential data drifts and so on. So there's some examples on that. But if you want to learn, like really start learning in detail about DeepChecks, there is a good article created by the community, and there would be a link in slides. So, yeah, I think there's some questions or something. Okay. So there is one of the examples when we could leverage such tools, such combination of tools as CML plus DeepChecks. Basically, as I showed you an example with quality of operations monitoring for ground handling in airports, there's a multiple of small tasks which depends on the accuracy of the detection of the airplane, which is like kind of obvious. One of the such tasks is that, for example, we need to understand that this ground handler is doing like signaling. I don't remember the term, unfortunately, like doing the signaling like properly. And it consists from two main elements. One of them is detecting like the position of the airplane, and second one is detecting the position of ground handler and detecting the distances between them, calculating the distances, and detecting the pulse of ground handler. I will touch a little bit on the detection of the airplanes because it's kind of more general task, and it may look like it's something simple. You could just like use something like YOLO to quickly spin off the object detection and get the coordinates of the airplane. But there's some problems. So one of the big problem is variability of the data, and as a result, variability of visual features. So when we are thinking about what is the airplane, we have like some visual features which combines and creates which combined creates for us the understanding of, okay, this is airplane, it's based here. But for computer vision models, we may get a little bit confused when we are working with different varieties, different types of the airplanes. And it's a relatively easy use case when we are working with such examples, as you can see on the top left corner. But actually, the bottom left is like actual aircraft. And it's really hard to predict that it is the aircraft or not, something like that. whale or beluga, I don't know. And this one is also maybe the aircraft quite soon. I think unfortunate, but it's the reality. And there's also other potential environment conditions which affects the computer vision models and affects the accuracy. And once again, so we are talking here not only about like accuracy because we want like to improve the overall solution and the numbers matters. The main part which matters the most for us is that actually in this industry, unfortunately, the people who are servicing the airplanes, like at least like 2 to 3 people dies every year, and so that's the goal, like prevent these deaths, prevent safety incidents. And when we are looking into solutions which show we are agnostic to any changes, like show work good, have extreme accuracy in such environment as a fog, partial visibility, the task of object detection is became much more complicated. So even detecting like quite popular category like airplanes became a bit different. And there is like another example of nighttime and abstraction. So we want to be able to see this particular airplane in the middle bottom, but it's being abstracted by other airplanes, and the night conditions does not help with accuracy. So how? So there's a couple ways what we can do here, and how particularly DVC helps us. Proper data version control helps us to understand if different combinations of data set elements have the valuable impact on particular computer vision model. So when we have hundreds of thousands of labeled images of that particular environment during with different environmental conditions like fog, daytime, nighttime, abstractions, and so on. We have like prior to using the DVC, we just had like a bunch of different folders, subfolders, just being hosted on AWS S3 storage. And we always had like to manually to create some combinations and duplicate. We have been always like it just was like always kind of a mess. So we always have been like combining different like folders and basically duplicating all the data. As soon as we started using DVC, experiment became much easier because we are just like creating the configuration which points out to particular like snippet of information. When specific computer vision engineers started working on one of the tasks, so for example, as we are talking here about airplane detection, if they're starting to working on airplane detection, they're just pulling just a snippet of data using the DVC pool. They're just pulling the snippet of the data which is relevant for this particular computer vision task. They don't need to understand the whole complexity of different data available for work. They just like could easily start just using like simple one line of the code. So how this all works combined? Basically, we are using the DVC part for data management, CML part for workflow experimentation, and I will start explaining about the third component, which is DeepCheck and quality assurance of computer vision projects. So basically, there is like multiple metrics used for computer vision quality assurance. One of them is like pixel accuracy, measuring pixel accuracy. So, for example, just like basically counting how many pixels we guessed correctly, if disregarding the position of these pixels, disregarding like the additional knowledge about the environment or about a picture. So as you can see here, here's like top-down view like of some port, and we counting like here the ships, but it could be the same for airports. But the problem here is that if we will just return the black screen result, it will provide 95% accuracy in such scenario. And there is some additional metrics which helps us to overcome these issues. So returning back to the example on quality assurance for computer vision model, as simple as airplane detection in different environments, to be able to serve our end customer with good accuracy solution in different environments as fog, night, and so on. We need to be able to properly understand and verify the results of our experiments. And these couple of slides, they show different approaches how we can verify the results and outcomes of these experiments. So there's a couple of metrics developed by community, by researchers, by engineers, by everybody working in the field, which helps us to understand if there was the outcome of this particular experiment of particular output, if it's valuable and accurate. And the problem here is that we not using the DeepChecks and we're not using automation tools such as the CML. We are kind of required to spend tons and tons of hours, literally hundreds and hundreds of hours of our computer vision engineering team. So basically, to deliver the high quality, high accuracy results for production in such a demanding environment as airports, we need to find a good solution for different environmental conditions. Environmental conditions here is fog and light changes in camera position, so on and so on. To be able to provide the proper solution for such complex, high variable environment, we constantly need to be reiterating on our data. We need to be constantly reiterating on our machine learning experiments, and we need to constantly be able to prove to ourselves that the solution which we create is actually highly accurate, not only guessed for just only for this particular scenario, but for truthfully accurate. And we need to run these different experiments. And what I want to propose to you is if you are working on, specifically if you are working on computer vision applications, computer vision software, or in general, if you are working on machine learning experiments in broad sense, to consider the following pipeline. So using computer CML for automatization of quality assurance process. In computer vision, that gives us extreme benefits. So basically, prior to automatization, we spend hundreds and hundreds of engineering time doing the manual reviews. After that, we started building a separate role in our team, computer vision specialized computer vision quality assurance person who have helped us to develop specific procedures for this type of the job. But it still was not enough. We started making some custom scripts and so on, but custom scripts, we need to maintain them, and we have a relatively small team, and we don't want to handle this all complexity ourselves. And the bright future, as I see it, as we see it, it's a combination of fully automatic CML and DeepChecks. So DeepChecks provide us with capability to detect the biases in the data, detect the biases and inaccuracies in the final results. So, for example, here you can see the visualization of bounding box location. So, for example, you could think that this orange square-shaped objects are airplanes which we want to detect, and here in this example we can see the difference between training data set and test data set, which helps us to get in the intuition about if our experiment is moving towards right direction. Also, there's some more advanced techniques which can be used inside the DeepCheck toolkit. For example, you could recognize. So this tool is called image brightness. It helps us to understand if there was some specific type of data drift into our data set. And if you look into details of the image on the right, you could recognize some parts of the shape of the airplane. So it provides you with intuition once again and understanding of what's maybe going wrong with a particular model or particular solution. I will also show you quickly some examples of Jupyter notebooks with a code and explain one or two more cases, and after that we will move into final vision of how this field gonna look like in maybe next year or a couple of years. So here you can see another simple example of potential issue between training and test data sets, so which was automatically generated by DeepChecks. Basically, we can see here that there was a bunch of overlapping categories in training and test data set, but there's obvious difference that there was no basket or TV or board categories in the trained data set, but they are presented in the test data set. So that could be potentially an issue for this particular model. There's also some other useful tools inside the DeepChecks. I'm not sure if you have enough time, but I will quickly show you some of the notebooks. The links to notebooks will be provided to you, so you could look into the details of the code, experiment with them yourself. So it's just simple Jupyter notebooks hosted on Colab. It will include all necessary steps, for example, including library setup, packages setup. I modified. I just tested them myself. Everything works fine as of today, and it automatically downloads the data and starts running the experiments for you. As soon as you finish all the basic steps, it generates the HTML report. And this HTML report actually contains the most value in terms of the quality assurance process. So you can see here in the report the visualization of quality assurance procedures similar to what I explained, to what I showed in my slides. So, for example, here you can see the details of distribution between different categories and different other metrics which is relevant for such use cases, such scenarios which we see in computer vision. So, for example, here you can see if there was some particular drift in one of channels, data channels for computer vision data channels, usually means red, green, or blue, or depth channel. And here we are looking if there was some issues in brightness, red, blue, or green channels, which may be extremely relevant for unpredicted changes and potential failures in computer vision models. Sorry, it probably sounds a little bit too complicated, but all useful information would be here in the notebooks and the slides, so you could look into this or send me questions at any time. And there's a couple more notebooks also included inside and specific for particular types of computer vision procedures which we have. Or, for example, we have here a notebook which which works with object detection function. So it have like one step which helps us to visualize what actually we are looking into. I think here is a data set is based on like tomatoes detection or something. And the same approach we are using the DeepChecks to generate the quality assurance report. It have like basic metrics like average precision, average recall, automatically generated and nice charts, and it's nicely combines with CML tools like TensorBoard visualization. So these all plays out nicely together when you're starting automating and integrating all the pieces. So if you're using TensorFlow, you could use a TensorBoard integration from CML. I'm not sure how much time I still have, or maybe I will just like move right to towards the end.
Ideas so that we have time for questions before we move to Yella.
Yeah, thanks a lot. Thank you, Jen. So there would be additional links and there would be a separate notebook which helps us to export everything in Markdown MD format, which you could easily integrate in CML. So that's it's going to be available part of. What else? I will skip some slides here just to save time. Okay, so the big vision here is that the main, like one of the big issues is cost of experiments, of computer vision machine learning experiments. It's not only the need and time, but it's also like general like time constraints. We cannot run enough experiments with small engineering, small computer vision engineering teams. And the big vision here is combining all these toolkits together in the pipeline, where we are not only using the DVC for managing the data, CML to run our deployments and test environments, test experiments, but we're also integrating this with future elements of creation of next machine learning experiment, and how we define what we want to test. Right now, we spend engineering time to look into the outcomes of our quality assurance metrics, of our previous like visualization of our experiments, and so on. And engineers spend their available time to create like additional experiments. But in future, we could create automatic experiments based on the automatic tests from CML plus DeepChecks. And we could nicely combine this with synthetic data. So another thing which we are doing in our company, we are using the 3D models to generate the data to train our computer vision model, computer vision solutions. Basically, it's like it's a Unity-based solution for creation of a bunch of examples of, this one is quick and nice. So basically, we are using Unity 3D engine to generate the objects which we are using for training of our computer vision models. And the big idea here is, can we automate all this? So use CML to run the test together with DeepCheck. DeepCheck provides the reports plus our own custom logic based on understanding of the environment, provide the recommendation for the next computer vision experiment which we want to run. And this goes into pipeline of automatic updates to the synthetic data. So if there is a lack of particular kind of the object in our data pipeline, we automatically generate more examples of these objects for our training pipeline and retrain the model automatically before even computer vision engineer will need to spend their time and look into results. So before they starting thinking about the next experiment, we are providing them already with 2 or 3 potential options of what these experiments could be and results of these experiments. So, and have like enormous potential to save a lot of time to everybody involved. Yeah, that's it. So yes,
thanks so much. There's so much food for thought in this presentation. Thanks for watching. If you enjoyed this product update video, please like and subscribe. Thanks, Stevie. And feel free to post comments and questions below. On our YouTube channel, we share videos on product updates, tutorials, and how members of our community use our tools as they solve problems in their domains spanning a wide variety of fields in the machine learning and AI space. Don't miss out on any of it. See the description below to find links in the docs for our tools. They are an excellent resource for getting started. Also visit our blog where you can find tutorials on our tools as well as product and company news. Join our Discord server to get support, help others grappling with the same issues as you, connect with other like-minded folks, and discuss our tools or other topics in the MLOps space. It's a great way to learn and get to know others worldwide who share your interests. We also have a job channel where you can find relevant job opportunities in the space. Finally, if you're really serious about taking your MLOps skills to the next level, we offer a free online course that is designed to help you understand the iterative philosophy and achieve your MLOps goals. Our mission at Iterative is to deliver the best developer experience for machine learning teams by developing an ecosystem of open, modular ML tools. Thanks for making it to the end. Dv and I will see you in the next video.